So let's take this one. Let's take this one. If v is equal to at plus v0. If I want to take the antiderivative of this, okay, I'm going to get, so I'm going to add 1 to this exponent. So this is t to the 1, so I end up with what? T to the 2. So I have at to the 2, and then I divide by my new exponent. All right. This is t to the 0, so I have v0. I'm going to add 1 to it, so I'm going to divide by 1. Okay? Is that cool? Now, this is where things are actually, to me, very interesting, because this is not actually the position, right? If you wanted it to be the position, you would have to add a plus c.
That's just the change.
That's right. So we can express this one of two ways. We can either say that, oh, I'm going to add the plus c, which is
x0.
the x0, absolutely. Or I could subtract this x0 from both sides, and I could make it the change. You see how that, we're going to end up with the same kind of thing here, but when you take the antiderivative, you're actually going back the other direction. And this is what this means. What if my graph looked like this instead? So it has the exact same shape, but started with a different initial position. How would the velocity graph be different for the purple one?
They would have a steeper, no?
It would be the same.
Because it's the slope of this, right?
Yeah.
So it would be exactly the same. The area would be the same. So the initial position is actually opaque to us. We don't know what the initial position is. Because when you take the antiderivative, you just add some sort of random plus c, or you solve for the change.
Oh, so, okay. So the time initial position would be helpful unless if we're trying to actually find like a moment in time where it's at this position.
Yes, so if they say, look, here's a velocity function, okay? Here's a velocity function, and then like, what is the position of it at? They're gonna have to tell you that, what the initial position was. And it's almost always 0. They'll say something like, hey, look, here's your velocity function. We know at time 0, the position 0. Where is it at time t equals 3 or whatever? So just keep that in mind.
Okay.
Cool? How do you guys feel about that? Like it? It seems vaguely familiar, yes? Yeah, I think it does too.
Sorry.
You're fine. I'm not annoying you. You all right?
Yeah.
No.
Just like tapping.
I just like tapping, man. I just like tapping.
It's a beat.
All right. Okay. So let's talk about projectile motion.
Oh, it was 2 E's, I was like,
I know. It just kind of came out swirly. So you talk about projectile motion. Here's the thing about projectile motion. It's motion in 2 dimensions, right? It's motion in 2 dimensions. It oftentimes manifests as, let's say an object, we'll do this case here. So,
I think you broke it.
The 2 E's are just
okay.
How? How is that possible?
the letter E. You changed it.
No.
You were unclear, it's fine.
There we
Oh
go.
my god.
No fun.
No fun allowed.
All right. You good here?
No. Yes.
Oh.
I'm joking.
It's a
So there's 3 things about this that are important. Okay? We need to be able to understand the horizontal motion, the vertical motion. So let's do the vertical first, because that's the easiest one to understand. So the vertical motion. The vertical motion is the same as free fall. Remember, the horizontal motion does not affect the vertical motion. If you drop a ball and you throw a ball, what happens? They hit the ground at the same time. The horizontal motion does not affect the vertical motion. Is that cool? So what we have here is we have free fall with constant acceleration, which is equal to our g value. So what does that do for us then?
Get us a 1 on the AP test.
Okay. Like, put your name on it, you get a 1. Nailed it.
Good to know.
Good to know.
Interesting.
So what we've done is, because we've moved to the vertical direction, I've changed my x's to y's. So we have delta y now instead of delta x. I've replaced the a with the g because we have now acceleration in the vertical direction for free fall. Instead of just initial velocity, it's initial velocity in the y direction because we're talking about the up and down now. Cool? And then if I want to solve for my y velocity, it's equal to gt plus initial y velocity. Look good? Now, let's talk about the horizontal direction, because the thing is, like, if I look at this ball, okay, if I look at this ball that I threw, any moment after I threw it, what are the forces on the ball?
MG,
Okay.
that would be it.
That is absolutely it. So are these forces balanced or unbalanced?
Unbalanced.
In which direction?
Down.
Yeah, towards the ground, right? So which way is it accelerating?
Towards the ground.
That's this.
-10.
It's negative 10 meters per second, right? But what about the horizontal direction? Are there any forces in the horizontal direction?
Horizontal is always 0.
Okay. So if there's no forces in the horizontal direction, what's that tell you about the motion in the horizontal direction?
It's not there.
What?
Well, it's there, but.
So what's it tell you?
Subspeed.
It's constant.
That's exactly what it tells you.
Constant velocity,
Mhm.
which means constant, or, no,
Means
know.
0 acceleration.
which means 0 acceleration, which means a linear path of movement.
That's right. So we have constant velocity, acceleration is 0. So we're going to use this equation, delta x is equal to 1/2 at squared plus v0 in the x direction times t. And this is what I was talking about earlier, where this is the equation, this is the kinematic equation formula, but if your acceleration is equal to 0, what happens to this term right here? It just goes away.
That's what's this initial velocity times.
That's exactly right. And what I like about this is we don't even use the 0 here, because if the velocity is the same the whole time, then we say vx t.
It's all coming clear.
This will actually really oh, that's what that was?
Yeah, no.
Well, it's because we move so quick in class too, that I lose, and then you miss a day and then you're
Then that's it.
Yeah.
Miss a day, you're behind 4. I know. It's
Oh, I missed 2 days and I have no clue what's happening in Calvary now. Absolutely no clue.
Did you have a clue before?
Yeah, I did actually. I had a 93 in this class, and I have a 91. So.
Oh my gosh. It's
The world's ending.
It is. This is the first one with A minus.
There's one more thing to this that you need to know.
I gave up on trying to get an A in this class. After the first quarter, I'm like, it's done, I'm just, a B is fine.
I did really good first.
B
quarter.
plus, I did too, I got like a 94.
Yeah.
Then it just,
I got a 7.
I did same grade.
So if you were to throw this ball with an initial velocity of v0 at an angle theta, can you figure out what the horizontal and vertical components are?
you could.
I hope you can. It's definitely something you're gonna need to be able to do. Okay?
Miss Nixon taught us well.
I didn't do very well in
That class stressed me out. I came out of the final of that class, like, was sweating through my shirt out.
That was also our first like high school files.
I know, it was bad.
that. Aww.
Oh, poor sweaty son.
Sweaty Simon. Poor freshman Simon.
Oh, poor freshman Jack. What a different person.
Okay?
Middle school.
So what you have here is when you draw it this way, where your angle is made with the horizontal, you can use a simple trig expression to write these two things. So the v in the x direction would be v0 cosine theta, because it's the adjacent side. And then what about the v0 in the y direction?
B0 tan theta.
How about sine? I know it's sine because the purple one, the v0, is the hypotenuse.
Isn't it so sad that like every year, whenever you take a class, and then like the next year when you take the next level up, you like are doing the same thing but with more, and then you realize how easy it actually was.
Yes.
Yeah.
Like next year when I'm taking like whatever the next physics is, I'm gonna be so sad.
That's how it was with pre-calc for me.
I know, now I'm just like, oh, that's how it was missed up these algebra when we took the derivative
Oh
test,
my
or
God.
the
But I got
factoring test.
15% on the factoring.
Factoring test was my first ever C. I so
And
bad.
what grade?
8.
But that class was also not good.
Okay, but I figured it out because Henry had a Martha.
Was it that?
Oh my, I remember her. Where did she
She's
go?
at like an honor school in Texas or something.
So,
Makes sense.
you could do-
Oh, like that.
You could do you can do it back the opposite way also if you needed to, like, if you knew the horizontal and vertical components, you could then go backward and get the resultant. Okay,
Sick.
does that make sense? So, in the initial problem, you're given the resultant, you have to figure out what the components are, but if you know the components, you can go back and get the resultant. Okay? Look good?
Yeah,
So far, so good?
What is that noise?
That's the elevator.
it's the back.
Oh.
So the elevator, I think it works on hydraulics. And so occasionally the pump has to kick in to keep the pressure where it needs to be. So that's the pump, the hydraulic pump.
It's like machinery that's uses pressure. First things. It's the hydraulics were really quick there.
My bad.
They go up and down.
Hydraulics go for.
I was the
Dude,
day
how do
before
you-
break.
Jeez.
This smartboard is really easy to do that on. I realize.
Oh, really? Do you want to get up there and show us?
Yeah, I think Mr. Patterson.
It's fine, just stay where you are.
I'm not good enough.
You're good.
I don't have to prove myself.
I don't have to prove myself to you. Okay,
But I was trying, and it was actually not that hard.
yeah.
Oh.
So if we watch this little stopper go around in a circle, right? We can talk about some centripetal, right? We can talk about some centripetal motion, yes?
Or from projectile.
Yeah.
Oh,
That was it. We're moving on, man, we're moving on.
I'm drawing the lines.
No. That's a different message.
You have a D in this class?
No, Mike is good now.
Yeah, I still do.
I will not.
One to get an A plus.
Same.
I will
Centripetal.
not. Do you see a D in that anywhere?
That's why I asked a question, because I'm unsure.
Good for you.
Apparently it's wrong to ask questions now.
Yeah, it is.
Which I don't think it
You may not ask questions. So it's called centripetal. They still call it centripetal.
is.
But-
Yeah, what's the difference between centripetal and centrifugal?
So
Damn.
Anywho, moving on.
It's not a TA in college, it said centripetal, man, that's how it's in my head now, I don't know what to tell you.
Oh, so it's the same thing?
Yeah, it's the same thing.
Oh,
It was just
no.
different pronunciations.
I was so confused for like a
Wait,
month.
really?
Yeah.
So, if you look here, the word trip is in the middle.
No, I get that. Well, RJ Richards every day would get on me about saying centripetal, and I guess like whatever, and he thought I.
There's
You
no
know,
C's,
centripetal.
there's no C's, there's no F's.
So I'm not. I
Bro,
just-
who makes fun of someone for actually, never mind.
So,
It's
I
RJ.
made fun of you for pronunciation.
Yeah.
if the speed is constant, where does the velocity point?
It works for them.
No, close though.
Oh, no,
This
down.
is tangent.
Oh, side side.
Goodbye.
Velocity is always tangent.
Day that I missed.
Velocity is always tangent.
That must suck.
Ow.
Ow.
Okay.
Is it always in counterclockwise?
That's just how I drew it.
Okay.
I gotta draw it. And what way does the acceleration point?
Inward.